friends, in this session we will study about the inverse of a matrix. So we could find out the inverse by different approaches. There are two major approaches which we use to find out the inverse of a matrix. Number one is by elementary operation. Elementary operations of rows or columns. Number second approach is by adjoint matrix. Through adjoint matrices, we have to find out the inverse of matrix. It is the application of determinant we use here in second method. So we study about the inverse of matrix through adjoint matrix. So first of all, I would like to tell you the formula regarding this. A inverse is equal to matrix adjoint A over determinant of A. This is the formula for this. So this we have to keep in our mind. And adjoint A, what is adjoint A? I would like to explain you here. Adjoint A, just a moment, I change the color first. Adjoint A is transpose matrix of the cofactors C11, C12, C13, C21, C22, C23, C31, C32, C33. This is the transpose of the matrix of the cofactors of a matrix. Now, what is C? Cij is equal to minus 1 to the power I plus j and mij. Here I is the number of row and j is the number of column. So we have to put this here, mij, the minor of that element we have to put here. So this formula we have to use to find out the matrix. So these are the some formulae which I have written here. So we have to use this formula to solving out finding out the inverse of a matrix. So adjoint. So first of all, we find C11, C12, C13 through this formula Cij. So we start with C11. So it is C11, C11, we get here minus 1 to the power 1 plus 1, I is 1 and j is 1 here, and M11, what would be the M11? First I would write down that particular question here. A, we have a matrix A of which we have to find out the inverse. So I am writing down here 1, 2, 3, 2, 4, 5 and 3, 5, 6. This is the matrix we have. And A11 is, this one is A11, the first element, first row and first column, and we have to take the that particular from here. So we have to leave the elements of first column and first row. The remaining elements we have to write here, the 4, 5, 5, 6. This we have to write here. So we get here minus 1 to the power 2, and here we have to take the product of diagonal, which is 4 into 6, and subtract the product of off diagonal elements of the off diagonal. So 5 into 5 we have to subtract from this. So we get here minus 1 to the power 2 is 1, so there is no bother about it. 4 into 6 24 and 5 into 5 25, so it is minus 1. We have the cofactor of C11. Similarly, we find out the cofactor of C12. C12 minus 1 to the power 1 plus 2, so it is the odd, so we get here negative sign, and minor of this we have to leave up the second column, and first rows 2 5 3 6 we have to put here 2 5 3 6, so we get here negative sign because it is the odd power is there on minus 1. So we get here the product of diagonals, elements of the diagonals, it is 12, and the product of elements of off diagonal, which is 15. So we get here inside this bracket minus 3 and outside is negative sign there, so we get here 3. So it is the 3. Now I think you would have understand how to get this cofactors. So now I directly write down this 1 3. It is the sum. Sum is even, so we don't take any negative sign here. So C13, what would be? C13 we have to leave this column, and this row 2 4 3 5 we have to put here. So 2 4 3 5 I have to put here. So we have to take the product of the elements of the diagonal, 2 into 5 10, and subtract the product of the element of our diagonal, this 4 into 3 which is 12. So get here minus 2. Now C21, it is odd, 2 plus 1 is 3 which is odd, we will take negative sign here, and C21 would be, A21 is this 2, so we have to leave this row and this column, the remaining elements we have to put 2 3 5 6. It is 2 3 5 6, so we get here 6 2 times 12 and 15, 3 into 5 15, so get here 3 minus 3 and minus, it will be 3. Now C22, it is the sum of 2 plus 2 is even, so we have to take the positive sign, and the elements of minor A22 we have to take. So it is A22 is this one, so the elements of 1 3 3 6 we have to take 1 3 3 6 here. So we get here 6 1 times 6 and minus 9 which is minus 3. C23 we will take here, it is negative, it is odd, 2 plus 3 is 5, so we have to take negative sign over here. So we will find C23 element is this one, A23, so we have to leave this column and this row. So 1 2 3 5, so we have to take 1 2 3 5. So you get here the product of the elements of the diagonal, 1 plus 5 5, and subtract the elements of the product of diagonal, 3 into 2 is 6, so it is 1 now, it is minus 1 and minus, it is 1 now. Now C31, it is even, so we have to take the positive sign here. C31, A31 is this element, so we have to leave this column and this row, 2 3 4 5 we have to take, 2 3 4 5, so it is 10 minus 12 which is minus 2, 2 into 5 10 and 3 into 4 12. C32, it is the sum of 3 plus 2 is 5 which is even, so we have to take negative sign, so we can take here. A32 is here, A32 is 5, so we have to leave this column and this row. So 1 3 2 5, 1 3 2 5 we have to take here, 2 5, so we get here 5 minus 6 which is again 1. C33 we have to take, it is 3 plus 3 is even, so we have to take the positive sign. C33 is this one, A33 is 6, so we have to leave this column and this row, 1 2 2 4. 1 2 2 4, so we get here 4 minus 4, which is 0. Now we would find out adjoint A. The adjoint A is C11, C12, C13, C21, C22, C23, C31, C32, C33. So I will write here adjoint A C11, C12, C13. C11, C12, C13 is minus 1, 3, minus 2. We have to put here minus 1, 3, minus 2 have put here, and C21, C22, C23, 3, minus 3, 1 we have to put here, 3 minus 3, 1, 3 minus 3, 1 we have to put here. But then C31, C32, C3 minus 2, 1, 0 we have to put here, minus 2, 1, 0. This is the adjoint A. We know that the A inverse is equal to adjoint A over determinant of A. So we can write in this way. We could use A inverse is equal to 1 upon determinant of A into a matrix adjoint A. So for this we have to find out the determinant of A. We could easily find it out here. Determinant of A. Determinant of A is equal to A11 C11 plus A12 C12 plus A13 C13. So we get here A11 is 1. We know that A11 here in this A11 1, A12 2, A13 3. 1 2 3 is there 1, and C11 is minus 1. A12 is 2, we have seen there, and C12 is 3. A13 is 3 and C13 is minus 2, so we get here minus 1 plus 6 minus 6, so we get minus 1 determinant of A. Okay, so we have to put 1 over minus 1, and adjoint matrix we know that here it is minus 1 3 minus 2 3 minus 3 1 minus 2 1 0. This is the adjoint matrix adjoint A. So we get negative sign inside, we multiply, so we divide this minus 1, or we could multiply minus 1 here. We get 1 minus 3 2 minus 3 3 minus 1 and 2 minus 1 0. This is A inverse we have got. In this way you could easily find out the value of A inverse through the adjoint matrix. One thing there should be, we should remember always, if it is a singular matrix, the value of whose determinant is 0, then it is not invertible. The matrix is not invertible. This thing we have to keep in our mind, not invertible. If determinant of A is equal to 0, because if you put A determinant of A as 0, it would be infinite. We cannot get the value of it is not defined, so we cannot get the value of the matrix whose inverse of a matrix whose determinant is singular. The value is 0. So in this way we could easily find it out. Thank you.